Recently I came across this dataset called the Danish fungi dataset. I thought it would be neat to take a crack at making a mushroom identification model, but wanted to take a slightly different approach. See, a lot of single input models are made to tackle problems like these. That is, they take one image in and output one prediction. The rule of thumb for neural networks is they're usually great at any cognitive task a human can do, and if possible, the model should approach it the same way a human does. These are completely fine for a lot of tasks, and people have made some solutions that do a fantastic job. The current highest accuracy solution is 81%, and by all means is very impressive, but I think using a traditional model for this is neglecting something very important. This is a video of Paul Stamets explaining the differences between two mushrooms that look nearly identical. The key difference is that one is edible and the other will painfully kill you. Knowing this, that 81% doesn't seem quite good enough. If you were presented with 5 doors and 4 have a tasty snack behind them and 1 has an agonizing death behind it, you'd probably pass up on the snack. See, mushrooms are identified by looking at their gill shape, cap shape, color, smell, texture, size, substrate, spore color, and so on. Fortunately, it can be done pretty reliably using only the visual methods I mentioned, but in a lot of cases they must be used in tandem. No one in their right mind is walking into a forest, seeing a mushroom out of the corner of their eye, and confidently classifying it. But this is what the traditional models are attempting to do. So my idea was, I could first train a traditional model to classify mushrooms, then convert it to be a Siamese model that takes in 2 images of a mushroom, one top view of the cap and one bottom view of the gills. Hopefully then, it can increase its accuracy since it has extracted more vital features of the mushroom. It's quite a large dataset, and I just wanted to do a bite-sized project to test this, so I'm only going to use about 30 mushroom species. I need to pick groups of species that are easy to mistake for each other, species that have photos throughout the entirety of their life cycle, and the species must be diverse groups of fungi. For example, I picked a few of the Trametes sisters, the most popular you may know as turkey tail. All of these look extremely similar, and I continued this pattern of choosing diverse groups of closely related mushrooms, so it's no easy job for a human or a neural network. I should mention I also included fly agaric, which is very distinct because if the model is failing to identify this, I know something is horribly wrong and needs to be investigated. After I cut the dataset down to just these species, I began exploring it, and there was a lot more noise than I expected. There were microscopic images, spore prints, images where a mushroom wasn't visible, dangerously misclassified images, and even oil paintings and a bunch of photos from one old man who took some lovely photos of himself, but failed to capture any fungus. I also made the decision that since the substrate a mushroom grows on can be critical to identifying it, and that can be determined visually, I should only include photos of mushrooms in their natural habitat. Any photos where mushrooms have been brought home and placed on a table or held in a palm will be discarded. It may seem like I'm being picky, but if you feed your model garbage, it will make garbage predictions, and again, because a garbage prediction could kill you, we want the highest quality data possible. Images are considered unstructured data, and they are notoriously difficult to clean and weed out the outliers. Since they don't have an inherent numerical value, how can you tell it's an outlier? This is a very common problem for a lot of projects, and often they're manually cleaned in a slow and tedious process. I didn't have the time for that, so after some experimentation, I made a little algorithm that did a wonderful job. What it does is compare the average pixel value for a single image to the average pixel value for the entire class. Then you can order them by their distance to the class average, and the furthest away ones look like this, all sorts of stuff we don't want, and the ones closest to the average were mostly high quality photos. Now that the data was nice and clean, we can start training the model. So first I decided to use the beloved efficient net, and specifically B2, mainly because resizing the images smaller than 260 by 260 pixels seemed to lose too much information. I took off the head, froze most of the body, and put a simple new head on. I set it up so the images were augmented on the fly, but I had to be careful they weren't too augmented. Shifting the images to the right or left too much could move it completely out of frame, for example. This was another area where the fly agarics came in handy. If my model couldn't identify them, it probably meant they were being augmented too much. I didn't train it for too long, and when it hit 75% validation accuracy, I started converting it to a Siamese model. So again, I cut the head off, duplicated and froze the model, set up a layer that joins them together, then put a new head on it. This new head didn't have to do anything too crazy. Basically, it just had to train until it understood what combined features identified what mushroom. The underside of two mushrooms may look identical, but the top may be different and vice versa. It hardly needed any training to learn this, then I got to testing. First, I ran the solo model and found some images it incorrectly classified. You can see it classified this mushroom as this nearly identical looking species. Honest mistake, you could tell me these two belong to the same species and I wouldn't think twice. But then, if I find an image of the underside of the mushroom and submit it to the Siamese model with the original image, it very confidently corrects the right species. I spent some time repeating this to verify it wasn't a fluke and was very happy with the results. Before I end the video, I want to show one other cool thing. Since all the photos contain the natural environment of the mushroom, you can take a photo of a random patch of nature, and if you run it through the model, it will return a list of mushrooms you'd most likely find living there. Of course, it should be taken with a grain of salt, but I tried it with quite a few pictures and it yielded the exact results I was expecting. That's it for this video. Bye now.